that you won't be neutral. Thank you, Professor Ramanathan.
Thank you, Dominic. I'm quite delighted and honored to be here. I was going to take some, 5-10 minutes to explain to you what's happening with the climate system now and what do we expect to see to happen in the next few decades or longer, and what can we do about it. Okay, so these are some of the remarks I'll make. Should I be operating that, or? Yeah. So, what was the joke?
No, it's just...
All right. Let me just, that's right, yeah. What we see, I'll explain my statement there, just to get us an understanding of why the climate is warming and why human activities are blamed for that. As we know, the industries and various human activities, we are putting numerous chemicals in the atmosphere. Some of them we call greenhouse gases. Carbon dioxide is the most well-known one, which is what comes out of your cars and trucks. But it's not limited to that. There are numerous other gases. And these gases basically surround the planet like a blanket. And I'll show you in the next dramatic video of how these gases travel around the planet. So think of it then, we have been dumping these gases in the atmosphere over the last 150 years, if not more. And so they've surrounded the planet like a blanket, and we know it from the observations. So the question is, why should we worry about this blanket? Let's go back and ask why a blanket keeps you warm on a cold winter night. Of course, in this room, there's no blanket, we are still warm. But the blanket keeps you warm on a cold winter night, not because the blanket is giving any heat to you. It's simply because the blanket traps the body heat. And that's exactly what happens with these greenhouse gases. You see, as I show in the arrows in the planet, the basic energy which drives the whole climate system, including life on Earth, is sunlight. Okay? So the sunlight heats the planet, and then the planet gives off this heat, and we call it infrared radiation, heat radiation. And it is this heat, just like the heat given by your body is trapped by the blanket, it is this heat which is trapped by the blanket of greenhouse gases. We know exactly how much they have done, and there are enormous amount of measurements. These are not model speculation, these are really observations. So based on the data provided by what's called IPCC, this is a United Nations body of over 1,000 scientists, I have concluded that we have already put enough greenhouse gases in the blanket, in the planet, to heat the planet by over about 2.5 degrees, close to 2.5 degrees Celsius. And that, by the way, is sufficient, according to the European Commission and the United Nations and numerous other bodies, to push the climate system beyond what's called dangerous threshold limit, or I refer to them to make iconic changes, and we'll talk about that soon. Watch the next movie closely, and the clock would be ticking by the day. See, and it basically shows how pollution and air parcels move around the planet. Okay, you see the clock ticking on the bottom. If you see from China, in a matter of 3 to 4 days, pollution travels all the way across the Pacific Ocean or the US. So while we are receiving pollution from China, we return the favor to Europeans. If you see across the Atlantic, the pollution travels in a matter of 2 to 3 days over Europe. And likewise, European pollution travels across to Asia. So basically what you see, and also you can see pollution, how from the Amazon biomass burning dives all the way into the Antarctic. So each one of us is in someone else's backyard. So we are not going to solve this problem by pointing fingers. Oh, the Chinese are emitting more, and the Chinese say the Americans are emitting more. the atmosphere we share, so is the oceans, okay? So you can't tell me anymore where the pollution is coming from, US or Europe or China or India. It's all mixed up in a blanket, okay? So let's talk about what I mean by these iconic changes. I think you have to stop the movie and go to the next one. Ah, very good. Thank you. So, what I show by the curve is, our uncertainty about the climate is so large. The blanket, which is already up there, can heat the climate system anywhere between 1.5 degrees to 4 degrees. So that's the range. That is why this problem in my mind is so threatening in terms of the future. If it is about 1.5 degree change, that's still large, but I think we can almost figure out how to adapt and cope with it. But if it is 4 degrees, then you can see, as I've shown there, one by one, major icons will fall down. The first one to go would be the Arctic sea ice. It plays a major role in the energy budget and the ecology of that region. Next to go would be the Himalayan Tibetan glaciers. To me, that would be an unmitigated catastrophe because those glaciers provide the headwaters for most rivers, the Indus for Pakistan, the Ganges and the Brahmaputra for India, the Mekong for Vietnam, and Yangtze River for China. All these, the headwaters come from Himalayan glaciers. And when the temperature exceeds about 1.5 degrees to 2, it turns out most of those glaciers would disappear. Okay, the perennial rivers won't be perennial rivers anymore. And then next, I'll show you something about the Greenland ice sheet. We all know if the Greenland ice sheet were to disappear, we are talking about 3 to 5 meters minimum increase in ocean sea level, so on and so forth. So the question you can ask is, I'm basically claiming this is not what I'm talking about in the future. This is already gases we have put in the planet. So you can ask, how much have we seen? We have only seen about 1/4 of this 2.5, just about 0.6 degrees. So you can ask, what's going on? One likely explanation, of course, there is some problem with our models, but there is something else going on. And that is, as we are putting these gases in the atmosphere, by sheer accident, you can call it dumb luck, we've also been putting particulate. This is what makes the sky hazy. And we used to think of them as urban haze. But as I showed you in the previous movie, these pollution particles travel vast areas, cover the oceans like a blanket of pollution. I call them atmospheric brown clouds, and reduce sunlight. Why does this sky look hazy? Because it's bouncing sunlight back. So basically, this greenhouse effect has been masked by this particular pollution. And we have estimated almost 50 to 60% of the warming has been masked. But we have to get rid of the pollution because they have other collateral damages. They have health impacts. They cause acid rain. They cause regional drought. So, and as we reduce this pollution, we will remove the mask and we will see the true nature of the greenhouse beast only when we get rid of the mask. And in fact, it's already happening in Europe. As you know, Europe has taken tremendous steps to clean up, cut down the sulfur pollution, and cut down the particulate pollution. And the warming over Europe, at least a factor of 2 larger than the warming you see over the US, particularly in the springtime. And in fact, the Eurasian snow cover has shrunk quite a bit. So we are seeing all of this unmasking effect. And I think the last thing I would want to leave you with the data coming on the Greenland ice sheet. The ice sheets build up during the wintertime because you have snow cover falling on it, building up, and then they melt. Over the last 2 years...
Professor Ramanathan, sorry to interrupt. What is there on this map? Can you tell us what we're seeing here?
Yeah.
What is it?
Of course, first you see the whole Greenland area. The blue is where the ice sheet is losing mass by melting. And the red is where it's building. So the red is positive. And normally, at least until about a few decades ago, the buildup and the melting balanced each other. Now it's gotten out of balance just the last 2-3 years. So we don't know if it's a long-term trend, but if this were to happen, then it would have a major impact in terms of how rapidly the ice sheet is disintegrating. Thank you.